Okay, we are recording. And I'd like to welcome everybody to this event. This is the final event of the Fall-Winter series that has been sponsored by Improving. This event is also sponsored. Splunk has come in. Thank you, Will Reeves, as well for that, to come in to also support us. So the agenda is as follows. You can see it up on the screen here. We have three speakers today. Brian van der Voort of VP Improving in Calgary. Mervin van der Spuy, who is a consultant, a former CDO, and also he's running a company now called Augmented Humanity, which I hope you'll hear a little bit about. And Dr. Reda, Alhajj, researcher, academic, and also expert in the field. And he is coming from the University of Calgary. My name is Wade Walker with DMC, and we can see the agenda here in front of us. We'll have an introduction to our two sponsors. So that would be Improving and Splunk. And then we will go into the event itself. There will be about 25-minute presentations, which will take us to about 12 o'clock, where we'll have a 5-minute break. And then we'll follow up with Mervin van der Spuy, and then we'll go into to the panel where the three speakers, we can delve into the subject matter a bit more fulsomely and ask questions. And I would also ask the audience or invite the audience to pose questions in the chat box, which will be curated. And also I will be asking or mixing that in with the other questions as well, and the discussion debate that we have in the panel. So just some logistics. Can I ask everyone during the event, during the speakers' sessions, to mute your microphones? Again, just to repeat, put your questions in the chat window. This is the panel's anticipated, hoped to be an interactive experience. So so please do ask your questions. And of course, as I said earlier, this is being recorded and it will be shared with everybody who has registered for today's event.
So wait, as you are recording, if you switch host to somebody else, will you be able to continue recording? Or
it does continue recording, yes.
Okay, that's good.
I certainly hope so. I mean, for some reason, I cannot do a co-host. It's funny with Zoom, sometimes you can co-host, sometimes you can't. And at this time, it's not allowing me to co-host. So we will see, hopefully. So I suggest that we actually move over to the introduction from Improving. I'm going to ask Brianna Loughlin to give us a bit of an overview of Improving. Brianna, the floor is yours.
Thank you, Wade. Hi, everyone. My name is Brianna Loughlin. I'm the Business Development Manager here in Calgary. My role leading training services, community engagement, and customer experience. As you can see in the slide, it tells you a little bit about what Improving is, but I'll just tell you a little bit more. So we are a technology management and consulting services firm, and we are deeply rooted in our commitment to establishing trust, not only with each other, but our clients, partners, communities, and others. This is why it is an honor for us to be able to support events such as this one with the DMC, and especially special to take part in this series. Our Calgary office, our team specializes in software development services, business intelligence, data analytics, and data solutions, technical consulting, and training and mentoring of Agile and Scrum methodologies. So as you can see, with much of our key services and expertise focused on data, business intelligence, and analytics, we really did feel that our collaboration with the Data Management Conference Canada was quite fitting. If you have any more questions about who Improving is, or you want to learn a little bit more, do reach out. I will post my email in the chat box today. We really do hope you enjoy today's session and you get to learn something new. So that's all I've got today. And it's great to see everyone. Thanks.
Thank you, Brianna. And as we said earlier, Improving has supported several of our events, actually every Calgary in-person conference. Improving.
Improving.com, check them out.
Improving has supported our in-person conferences since we started doing conferences in Calgary, and they've actually supported the entire fall-winter series here. And I would like now to introduce you to Will Reeves from Splunk. Splunk has also supported our in-person conferences in both Calgary and Edmonton, and they've come in also to support this event. So Will, please, you have the floor.
Yeah, thanks, Wade. Appreciate it. So first, thanks everybody for attending. We're excited to be a part of this, and appreciate everybody taking the time out of their day to listen and learn with everyone. So thank you for that. As Wade mentioned, my name is Will Reeves. So I'm the regional sales manager at Splunk, and I'll take a few minutes and sort of introduce you to Splunk if you haven't heard of us, and yeah, and then send you off to listen and learn. So Splunk is the data to everything platform, and I mean that's a pretty general statement. So what does that really mean? Well, it means that we help organizations take data from any source in any structure and any time scale to drive outcomes. And typically we do this within IT security and DevOps. That's usually where we begin our journey with our customers. But we are a data platform and we do many other things. And so we're doing a great deal of work in areas like fraud and financial crime, industrial IoT, OT, and in general, providing business oversight or business insights across an organization with data, period. So I thought what would be helpful is to share a little bit, a couple examples of what we're doing, and more so are possible than our typical IT or security type conversations. So the first one I wanted to share is what we're doing with McLaren Racing. So McLaren actually uses Splunk, and they Splunk all sensor data from their race cars. So any part that is on a car that is moving or not moving that could generate some sort of friction or anything really on a car has a sensor at McLaren, and Splunk they're using Splunk to monitor, investigate, analyze, and act on that data, and really to just ensure that their cars are running perfectly and consistently or constantly improving. For those who know anything about racing, literally a fraction of a second could be a win or a loss. And so Splunk is literally helping McLaren win races, which is kind of cool. And then the second one I wanted to share is, I believe, fitting for the conversations and topics today. And that is that we are, Splunk is the core technology that's been donated to the Global Emancipation Network. And so GEN is a nonprofit organization of volunteers using the power of data to help over 45 million annual victims of human trafficking. So together with GEN, Splunk developed a solution called Minerva. And what it is it's a multi-tenant data analytics platform that enables secure, individualized data sharing and intelligent analytics. So this platform, of course, uses Splunk, and it takes messy, unstructured, and siloed data from hundreds of sources all over the world to make connections between things like usernames and email addresses, phone numbers, text messages, and even images, and really giving the ability to do something that could be virtually impossible to do if it were done manually, leveraging sort of Splunk as the engine for GEN. So some really interesting things that Splunk's doing, not only as a company, but to sort of help the world to be a better place with data. So with that, just again, thanks for having us, and enjoy the conversations today.
Thanks, Will. So yeah, and with that, actually, I think let's get started with our content. And to start with, I'd like to invite Brian Van Voort of Improving to be our first speaker. Brian, as I said, he's VP Consulting out of Calgary. Improving is actually an international organization. And Brian is very much focused on well, first of all, he's a practitioner for over 30 years in consulting of everything from software development through, and through analytics. And he's going to bring an interesting perspective on this subject matter. So Brian, I'm going to give you host, and I will stop sharing. And I will let you.
Thanks, Wade. Let me see if I can quite have host privileges yet.
Just for logistics, after you've completed your talks, maybe then you can move on and you can make Dr. Reda Alhajj the host after you. I don't seem to be able to make anybody co-host today, so you are now host, and you can go ahead and share.
Excellent. Thank you.
Can I just ask again, everyone, to mute your microphones if you're not speaking, so that we give Brian the full floor.
All right. Hopefully everyone can see my screen properly. This is, this is the, kind of first comment that people do on Zoom or Teams. And then the second is, sorry, you're muted. So I want to go in and just give you a bit of my perspective on how business value can be gained through advanced analytics. As Wade has alluded to, I've been a practitioner for about 35 years. I've worked in a number of different startups. I've been a software consultant for 25. And there's a couple things that I've evolved during my career, right? And one of these, I kind of say my core beliefs. One of my core beliefs is that data is underutilized by most organizations. I think we could probably say all organizations. All organizations are been collecting data and they're not taking advantage of it. And I see it part of our journey with our skills to help organizations, take advantage, make better decisions with their data. Some other things is, you quickly learn when you come out of school, you're an expert. But, after years, you realize that, I know less and less every year. But what I do know is I have experiences, and experiences matter because you can take what you've experienced before and apply those to new situations. Finally, but to talk about earning people's trust. And this I've learned is really important. If you earn someone's trust, then they will listen to you and they will, respect and understand your opinion. So there's lots of techniques to learn how to, build trust, but it is really important. So if you want to be listened, first establish trust. So I just want to talk a little bit about, improving as a company, but why does it matter? So we have, we got offices all over North America. We have, data-centric communities throughout, Canada, US, and Mexico. Some really great people. I just want to do a shout out because this presentation is not just sort of my experiences, but it comes from across our organization, talking to my colleagues in those offices and some of their experiences. So this is, this isn't just for me, this is across North America, what we are seeing. Here's my agenda. What I want to go through is, a couple of points, and I say try to keep this to our 25 minutes. We want to go in, I want to know, why should we care about advanced analytics or AI? Some of the challenges you might have, some thoughts on preparation, use case selection, project execution, how do you put things into production, and maybe some risks that you should be aware of when you are, utilizing advanced analytics. So we probably, hopefully most of us are familiar with the Gartner hypercycle, and I just have an example of the hypercycle here for 2020 on artificial intelligence. And it's a little small, maybe I'll zoom in a little bit here. But when we look at this, the hypercycle has, initially you started.
Tony.
Pardon me? All right, hopefully everybody can hear me. So when we go in and we talk about the hypercycle, we can see lots of AI technologies are sort of on the upswing here, which is talking about, we're going in this innovation idea, expectations are getting very high on that. And organizations are jumping on the bandwagon. What typically would happen is, organizations and society will figure out where the real benefit of AI and other advanced analytics technologies come in. We'll go into this kind of, they call it kind of the trough of disillusion. And then it will eventually go into, where we find the real value. So AI is kind of on the upswing. We're going to figure out where it can really add value. There's lots of high expectations. I look at situations like blockchain. 5 years ago, blockchain was going to solve every problem. Well, blockchain has some very good use cases, but it's not solving every problem. So let's talk a little bit about why we should care. And I'm referencing a really good article by McKinsey Group. They do a number of different global surveys, and kind of key points here. I'm going to pull a few of them out of their most recent report. It said that by 2030, AI could deliver initial global economic output of $13 trillion per year. That's not a trivial amount of money. So really means that we should be, as IT professionals and business professionals, we should be looking at, AI and how that can help our business. What's interesting though, even though we're, I'm going to say we're kind of on the early stages of the respondents to their survey, 50% said they are actively using AI, advanced analytics in their organization. And even better, 66% of those said that they are reporting revenue. And of that revenue, 22% said that at least 5% of the EBITDA, their revenue is driven by that. They're directly attributed to it. There's one point I want to make just around that is when they talked about it, there's two ways that you can increase your EBITDA. One is by increasing revenue, and they saw that AI for most of their clients was in that category. It was one where it was increasing revenue, maybe by increasing output, increasing sales. But there is aspects about you might be sort of reducing operating costs by maybe not necessarily increasing your sales or output, but you might be reducing your costs. Both ways to sort of look how AI might help an organization. A couple aspects around companies that have had successful programs, they generally have support and funding from the C-suite. So, you can go in and do this grassroots, but it does take a fair significant investment to get the right people and right ecosystem set up. And it is important for organizations to help build that internal expertise to go in and utilize that. And the final point they mentioned, which is kind of directly related to the fact that we're all remote here, with digital adoption due to COVID and other restrictions, they've actually seen a significant uptake on AI in organizations. With that in mind, I want to talk about some things that we've seen within our customers and some of the challenges they've had with adopting advanced analytics. I just want to talk about these briefly. I'll go into a bit more detail here, but first off, I hired a data scientist. We're good to go. Are you going to be looking for use cases in all the wrong places? We're going to talk about use case selection. Let's bake a cake. How do we actually build solutions? The product is the prototype. How do we actually deploy this within our ecosystem? And what did my chat bot say? Okay, am I getting the behavior that I expect? What I'd like to talk about initially is, building the team. A common mistake I've seen is organizations will go in and say, "Oh yeah, we have an AI program. We're going to be using ML. We're going to go do all this predictive analysis. I hired a data scientist." Well, that's a good start, but it doesn't end there. And, the data scientist can go in, help with some preliminary models and whatnot. But if you're looking for a solution that you are going to have your business rely on day in, day out, you need some more members of your team. You're going to need data engineers, data developers. They're going to have to do a bunch of data movement. Data analysts, maybe help analyze the data, looking for data quality, data anomalies. You might need a cloud architect if you're going to be putting this on a cloud ecosystem. UI designer, if you're going to put this in front of maybe clients or customers. Software developers. I've seen lots of people go in and they're using AI embedded into their software development options, into their websites. So we need some skills in that area as well. DevOps, we need to be able to go in and adopt practices from software development where we go in and push solutions in a trusted, reliable way to various different environments and ecosystems. You may need business analysts to go in and understand aspects of the business. And you're going to have to engage product owners and subject matter experts. So if you're going to start a program, hire a data scientist or two, but also realize that you need to build a full team to go in and execute these types of strategies, certainly in the larger enterprises. Other things to talk about from a technology perspective, this is a new technology ecosystem for most organizations. Sure, we do need to go in and look at maybe we will utilize a cloud provider. Let's select that cloud provider that we want to work on. There's new ML AI stacks. There's a lot of options out here. Each cloud provider has their own suite of tools. There's lots of tools out there that you can help that. You need to understand and evaluate those tools to make sure that you're making the best selection for your organization. There's data processing, lots of changes in that. Some of them ecosystem specific, others are more kind of standard development tools like data processing in Python or something, which traditionally hasn't been a strong tool in many organizations. Presentation layer, there's lots of tools out there that may end up, if you're looking for graphical presentations of charts and graph, the Power BI, the Tableaus, lots of options in that space as well. You want to look at data access. How are you going to access your data and do that in a secure way? So when you're going to start a program, let's get prepared. Let's talk about what your team needs are, and let's talk about your technology stack and what you want to start with. Other items that you need to understand is, what are the problems or use cases that you want to look at? And I've personally seen a number of cases where people say, oh, I've got a lot of data. I've got like 10,000 records and I want to do some AI on that. And I have to very politely indicate that that might not be enough information. Or we're going to organizations that say, yeah, I'm capturing all this information. And then of course we peel back the layer of the onion, need to find out that the information that they're capturing isn't sort of suitable for use. So typically you'll want a situation where you have lots of data information, whether it's structured or unstructured, to be able to go in and look at possible business value. And business value is the next point. There are situations, again, where I've gone in and we're looking at applying AI and automation, but there's some cases which, if I'm looking to save the operating cost of a facility by 1% through AI, that could be hundreds of millions of dollars. If I'm looking to save, a day a week for a worker, that might seem like it's a bigger percentage, but it's not as much value. So make sure you take a look at the problem space and where the value is, because this is going to be a big investment. We want to look at kind of complexity in the business domain. What I mean by complexity are, situations in business domains which have a lot of different factors can influence it. I look at this for something that might even sound simple, like, when should I change the oil on my car? Well, initially the easy answer is, oh, I do that when my dealer tells me. Well, it's a lot more complicated than that. There can be lots of other sensors and other information on these modern cars that can then be going and say, here, based on your driving habits, the temperature, the type of oil you've used, how you drive your car, lots of different factors could go into when the optimal time or the best time is to change your oil. So something that seems simple could be very complex. And the last one I want to talk about is situations where there may already be a model. I've got an engineering background, and I spent a lot of my first part of my career creating complex mathematical models to simulate chemical processing facilities. We had, there are situations, and I've been in clients where, they've been a complex modeling done only to the engineer to say, well, that's really good, but I have this, theoretical model here, which can accomplish the same types of things that you're trying to provide to me from a predictive perspective. So, when we look at this, maybe it is an advantage to take advantage of what was done before from a modeling perspective and apply it to yours, rather than going and recreating something that has already been done. Referring back to the McKinsey report, they identified 8 areas that their respondents were using AI in. And I'll go through these quickly, and I think most of them will make sense to us here. So they talk about, first one being product development. So that's enhancing AI products, adding new features to products. So that's, probably not a surprise, because, products are typically more focused on technology. So early adopters into that, you see all sorts of interesting uses of AI in, security and other software products that are out there. Service operations. So they've looked at organizations trying to optimize their service optimizations, or maybe do predictive service or interventions at a client who was looking at the same kind of things, about when should they intervene in a particular situation or with a particular client. Marketing and sales, lots of analytics in that. We're looking at customer segmentation and customer service analytics are 2 key areas that they highlighted in the report. Risk and risk management, fraud and debt detection, a large area for lots of financial institutions. Risk modeling, we work with the clients that build some risk modeling software based on some analytics as well. Manufacturing, from a manufacturing perspective, this is really relevant to us in Calgary here with oil and gas. We do lots of manufacturing output of oil and gas. So what AI is helping and looking at is increasing yield, reducing operating costs, increasing output, maybe even predictive maintenance on various different pieces of equipment. I know in human resources and talent management and performance management, there's usage of AI. I'm a little surprised it was that high up on the list because the one below there, supply chain, lots of work in logistics and optimization of that, as well as parts and inventory optimization. And finally, on this list, it indicated some work on corporate finances, and that was a lot around strategic capital allocation. Where do I spend my for those? So we, as an organization, we've had experience and we've worked with a number of organizations in here. We worked with an international semiconductor organization to go in and help their manufacturing process, increasing their output. We've done some work and looked at logistics for organizations. We've been working with organization in the travel business to go in and look at using ML and other technologies to go in and help their customers through their purchasing process. Looking at mining industry and again, providing output. A client I'm working with quite closely right now is engineering focused, and they're looking at extracting information from tens of thousands of documents and diagrams and trying then to give a picture to an organization about their level of risk. So lots of interesting projects going on, and these are not the only areas, but I think you'll find that every business probably has some aspect here which they could take advantage of some AI or advanced analytics to help drive business value. So this may seem like a very strange topic. We want to bake a cake. Well, when we look at baking a cake, what is baking a cake? Well, it's empirical. We follow the recipe for success. You know, this is a repeatable process. We do it all the time. It's well understood. This picture is of the Mars rover. You've probably seen it in the news recently. You know, it's highly complex. There are no instructions. It's never been done before. In fact, I think that many people thought maybe it wasn't even possible to be able to go in and land this rover in the new way they did this time. So what we're looking at are two different types of problem we're solving. One's very empirical. We follow the instructions. I bake a cake. It's a fancy cake. I might not be able to do that, but someone who's talented could bake hundreds of these just following the instructions. Then there's the one-off or very much more complex where there are no instructions. This is where advanced analytics projects live, in this more complex space. Agile, which is a process or approach which talks about embracing change and unknowns, seems really well suited for these types of projects. In the diagram here, this depicts a typical Scrum process where you put a product backlog. You may then, for your 2-week sprint, decide what you're going to do. The team builds that, and at the end of it, they review, they rinse and repeat, reprioritize their backlog, and continue this cycle until they eventually are done. Agile is very good at dealing with unknowns because we're only focusing on initially the end goal at the end of the sprint. Now, there are situations where you're in a project and you say, I've got a question. I don't know how to solve this problem. And typically in an agile process, what we'll do is add user stories or spikes to the backlog to say, I'm going to go in and investigate this maybe technology or this approach. And the goal of that spike is to answer a question. It isn't necessarily to have a working solution where the rest of the stories are intended to have, the outcome of those is working software or working, analytics. So yeah, this can apply, and you can go in and use spikes. And I've used that quite often in some of the projects that I've been working in. So what we do is, we're looking at that at Agile. There's a couple different ways to go in and slice Agile other than Scrum. I've used the same process using more sort of crisp DM model, where we go through the process of saying, okay, let's understand what we need to solve. We look at the data, we prepare it, we model it, we evaluate it, and there might be some outcomes. Most time you iterate through this many times. You might come to the point where you discard, which means we're not going to do any more about it. Or finally, you might say, well, we've done enough and we're good to move on from this project. One of the things that is really hard for people is to discard. And you may have heard people talk about, fail fast, fail often. What I think we need to do is switch the language around that. Is these iterative processes are made for us to learn fast. So it's critical for us to have processes, particularly in AI, so that we can learn fast. So we learn, we understand, because we know that we know we don't know everything. So again, it's not a cake. We need an iterative process. One of my colleagues, Abhay Agarwal, he's a researcher. He is an instructor at Stanford School, teaches design and machine learning. And he's also part of an organization called Polytopol. And Polytopol has defined a language to talk about human-centered AI. And there's a link there. You go to polytopol.ai, and you can go through the information there. There's one really key takeaway that I've taken away from the work that Abhay has done is his approach is based on validating or invalidating hypotheses. So in AI and advanced analytics, and probably in lots of other applications, what we're trying to do is answer questions. So instead of having a backlog of user stories, you can have a backlog of questions, and you can decompose each of those questions. Questions could start up as, can I use web blogs to measure success of a campaign? Can I use biometric information from your phone to tell if you had a seizure? Can I create recommendations that result in increased purchases? Is the data we have sufficient? So what it's doing is taking away the aspect of failing. All you're doing is answering a question. It could be yes or no, right? Is my data sufficient? Yes, no, maybe there's a gray area in there, but it's not like if you say no, it doesn't mean you failed. I really like the perspective that this has taken. Abe has several use cases that he's gone through end to end in this. Really good talk. He also has a talk on YouTube about this that may be interesting for some of you. I'll try to find the link and paste it in the chat window. So when we go in and we start taking AI solutions from the desktop to production, there is a whole ecosystem which is net new to a lot of organizations. Sure, we're used to dealing with various different data sources. If we're in the data world, we may be used to doing data transformations and whatnot, but there's new technologies and data structures and databases that we're using now. But we're introducing this concept of models. And if you have a lot of models, you may need a model registry. You need a way to go in and retrain your model. You need a way to go in and push your model out. How's your model going to be consumed? Is it going to be through some API or some other mechanism that it's going to be utilized by your organization? There's a lot to this. And people are referring to this, and I'm sure we'll hear more about ML ops. This really takes a lot from the software development world, which has gone in and automated and has processes and procedures to go in and, reliably, robustly take solutions, from the desktop, from the developers, all the way through your process validation to where it gets put in production in a way which, very complex environments could take days if you did this manually. So as you go in organizations and you're looking to move towards, using AI, not just a one-off experiment done by a data scientist, but actually embedding it into your systems, this is critical to understand and have ML ops, this sort of end-to-end processes in place. Moving on to final topic here, just a little bit about risks. And I look at, I've spent a bunch of time working with a company which focuses a lot on risk, and they talk about different types of risk, right? They talk about, reputational risks. I.e., is my reputation going to be tarnished? They talk about environmental risks. Does it, if there's a problem, does it cause any environmental harm? They talk about financial risk. If this event occurs, how is this going to impact my financial risk? And they talk about human risks to human beings. And these are all great ways to go in and characterize risks. And when we talk about utilizing advanced analytics, you've got things about model accuracy and bias that really come into it. You've got to go in and figure that out. Colleague who used to work at Google said they had challenges. They go down the road and say, oh, my autonomous car is driving down the road. Oh, I figured out that's a person. And I think they're going to, they're going to jump on the curb or jump off the curb onto the road. What should I do? And it's going to make some decisions. And the decision, but that might hurt the driver who is in the car. So what decision does the vehicle make in those particular use cases? So there's going to be decision and bias that is in there based on coded in or whether it is just by the data that you've trained your model with. There's data and privacy concerns about using some of these advanced analytics. Can you actually use the data you have? Are you getting it in a proper way? And there are things where things are used in unexpected ways. You'll hear people using Tesla autopilot and, deciding that they are, not going to follow the instructions and keep their hands on the wheel and have accidents. That caused some reputational risk because people don't trust your car. Several years ago, there was the Microsoft chat bot, which people, taught it how to use some politically incorrect phrases and other words. So all well intended, but you've got to be aware of some of the risks of the solution that you're building. So in closing, I just want to reiterate the process that I've outlined here for organizations that want to get started in it. First off, you've got to focus on building a team, infrastructure, and processes to how we're going to accomplish that. You need to, within your organization, identify business-focused use cases. You then need to go in and do data validation and preparation of that data. We have, then you need to go in and build your models, do some pilots and POC. And finally, you need to go in and think about scaling up and scaling out. Scaling up is taking and looking and saying, great, how do I apply this to, push this out to my production environments? But you may want to look at how do I support this going forward and expand it to different business areas within my organization. All right, well, I have my contact information here. I understand we're doing questions at the end, so we don't need to do these right now. But I thank you for your time and look forward to hearing the rest of the presentations today.
Great, thank you very much, Brian. Brian, if you can make, please, Dr. Reda Alhajj, the presenter, and I will just do a little introduction here. I've known Reda actually for a couple of years because actually he was working with one of my colleagues in the AI space. This would have been about 6 years ago, I suppose. Dr. Reda is, as I said, an academic. He's a professor at the University of Calgary. He's a researcher in data mining and AI, ML, and other areas that I'm sure he'll get into. And he's also organizer of a number of conferences, including one that is occurring this November in Den Haag, in the Netherlands. And also he also organizes the BIDMA conference, which often almost coexists at the same time as the spring conference in Calgary, the DMC. So Reda, let me go ahead and give you the floor. I believe you should have been made presenter by now. So why don't you share your slides, and we're looking forward to it. Thank you.
Okay, thanks, Wade, for inviting me. And let me start my talk. So today I will talk about big data and data analytics from an academic perspective, what we have done and what should be done. So I will give a general overview of my achievements, my group, and then I will go into some of the techniques we have done for scalable data mining, and I will try to write on the slides as I go if I need. So scalability is one of the most important concepts that has been encountered recently, and always we need scalable techniques. If you look in the literature in the past, they were assuming unlimited resources, and they were testing and saying that our technique works well, but if you put it in practice, it is not scalable. So we need practical, scalable applications and algorithms that scale well to big data. So we have been working on different aspects of data analysis in different domains, from bioinformatics, security, data management, manipulation, and so on. So as Wade said, I'm organizing a number of conferences. ASUNAM is the main conference I have been organizing since 2009. It is very successful. This year, we were going to go to Netherlands. We still have the hope to go to Netherlands if the situation will improve, but we may go in November. We had a tsunami 2020 in December last year, and it was a successful virtual conference. I am editing a number of journals with Springers. I am editing an encyclopedia with John Rockney at the University of Calgary. I have a lecture note series, and we organize a summer school. Occasionally this year, we plan to organize the school in case the situation will improve, or we may organize the school virtually. We concentrate on social network analysis and mining from different application perspectives. So I have been working with all data related aspects. I started with the traditional databases in the 80s, 90s. Then I moved into advanced data management techniques and data analytics. And as I said, we mostly concentrate on scalability, because without scalability, we will not be able to live and satisfy the needs of evolving applications that generate huge amounts of data, and we need to scale for large data. So we have been handling different applications in financial domain, in energy, in homeland security, recommendation systems, and so on and so forth. So data science can be broadly defined as making sense of and maximizing the benefit from data, leading to informative decision making. So you get multi-source data. We don't have a single source data anymore. We try to benefit from data as much as we can. We collect data from multiple sources, and we try to put the data in a certain format such that it can be processed. So in the past, we have a solid, rigid model where we have to fit the data in the model. Now, we try to fit the model to the data that we have. And by fitting the model to the data, we can flexibly process and analyze the data, leading to knowledge discovery that will lead to effective decision making. So we use the most important concept that we have to concentrate on, because without value from the data is useless. So the techniques that we develop try to make value from the data. So in the past, people were dealing with data-based management systems for storing and retrieving data, because they were ignoring the implicit content of the data, as they had limited resources to process and benefit from the data. And big data, very fuzz word, because big depends on what you have and what you want. For example, VLDB is a database conference that started in 1973. It is called very, very large database conference. At that time, they were talking about very large databases. While we were going to school in 80s, we had 512 kilobytes of floppy disks. Most of you who lived in that era know about 1.44 floppy disks, and 512 kilobytes floppy disks were used as external storage. So large data depends on what you are intended to have and what you already have. So if we look at the bottlenecks that we have faced over the time, the space is the main bottleneck. We cannot have unlimited space. Processing power of the computing resources we have is also another bottleneck. Network bandwidth is another bottleneck, but from data perspective, flexibility and elasticity of the modeling and handling of the data is the main important concern that we have. If we can have a flexible way of dealing with the data and extracting content from the data, that will help a lot in decision making. So the amount of data that has been processed and that has been captured daily is increasing even more than exponentially. And we are capturing huge amounts of data from different sources for different applications, and we should be able to manage and process this data. In the past, this was not possible, but now with the new techniques, we should be able to process as much as possible this data for knowledge discovery. So we should differentiate between two platforms, the SQL and the NoSQL. The SQL dominated in the 80s, 90s, then the NoSQL started to appear and pop up. But still, the SQL is dominating more than 70% of the market because there are big players that are trying to capture what we have and try to maintain the databases so that they can satisfy most of the emerging applications. If you look at the history of data and databases, you will see that we have manual process in the pre-computing era. They were handling data manually, so they were not able to handle large amounts of data. They had file cabinets. All the banks had files manually processed in the past. In the 60s, they started to use file systems for handling data, and they developed NoSQL storage and processing medium like hierarchical model and network model. But they did not survive much because the relational data model was developed in the 70s with mathematical foundation. So it dominated the market and will continue to dominate the market in the near future. It killed the object-oriented databases, which were NoSQL databases, because it absorbed all their good characteristics. XML databases survived, though XML was not developed and intended to be a data management tool. It was developed for data exchange. Because it is platform independent, it survived as one of the NoSQL databases. Then we had data mining techniques, advanced data modeling techniques, intelligent data analysis techniques, big data management. All of these are NoSQL databases, but still SQL databases are dominating for daily transactional data. They are very useful, very effective. We have the data is characterized by many V's. The most important of these V's is the value. If we cannot extract value out of the data, then our data is not useful. Volume is increasing. We cannot assume a static data. We cannot assume data that does not change all the time. So the velocity in the data is very important. Data is dynamic. Always you get streaming data coming in. So you should be able to manage this data and to process this data. We get data from a variety of sources, heterogeneous data coming from different sources. As the data is heterogeneous and dynamic, we cannot always talk about the consistency and correctness of the data and the values we draw from the data. We are handling uncertainty here. Connecting the different pieces from heterogeneous data and integrating different pieces is important. So we have to decide whether we want to integrate the data before we process or integrate the results after processing different sources. So as I said in the past, data bases and database management systems were used to store and retrieve data. So these were welcomed and well utilized in the past because they replaced the manual process, which was very time and effort consuming. But with the new era, we need to be able to extract implicit information, implicit knowledge from the data. So we should be able to answer questions that cannot be answered by traditional query processing techniques. Because of that, we need data mining, machine learning, AI, network processing techniques in order to analyze this data. Network is a very powerful structure that has very good roots in mathematics. Graph theory is very good supporting networks to construct and analyze the network. But the network remains abstract until you load this with semantics. So we can construct the networks by deciding on the nodes based on the domain that we have and the links based on our intention. For example, we may have the nodes as the students and the links between them, who wants to socialize with whom or who wants to study with whom. So then we can analyze the network in order to get some information out of this network. Data mining machine learning techniques are very powerful algorithms in order to analyze the data. From the outcome of data mining machine learning techniques, we can inspire a network. For example, we may cluster the data and we may connect nodes that appear in the same cluster in one way or the other. We can build a frequent pattern analysis model, and frequent patterns may be connected together. So once we have a network, we can analyze the network for knowledge discovery. As I said, we have dynamic data. We cannot assume unlimited memory. So we need to have scalable techniques that work with limited memory. Spark, Hadoop may not serve all types of applications. So for transactional daily data, organizations which have limited resources should be able to analyze and process huge amounts of data using their limited resources. We have developed techniques that deal with dynamic data that flow in and always changes. The volume of data changes, and we have developed techniques that can work with limited amount of memory by assuming the disk as extended part of the memory, so unlimited memory constraint is overcome by extending our processing to the disk. So if we look at some of the applications that we have developed and some of the tools that we have developed, we have analyzed networks in the security, in the homeland security domain. Inspired by September 11, let's say Madrid attacks. So if you look at these terror or criminal networks, you will find that always data is incomplete and may not be fully correct. We have data collected from different sources, so we have to transform and integrate data in order to process the data for more informative result, a full picture of the as close as possible to a full picture of the outcome. So we have fuzzy boundaries. We don't know who to consider as part of our network, who not to consider, who to identify as a suspect and who to omit from the network. So the network is dynamic, people move around, and you have to capture the dynamics of the network. In the past, people were processing documents manually in order to derive the network. This was not an easy process. They were only able to process limited networks and limited data. So we can, instead of having this manual process, after September 11, the work on more automated systems became very popular, and we have now many network processing tools that can inspire from the data and can display the network, analyze the network, and discover in the network. So we have built our own tool for network analysis. We can look in the past to learn from the past, and based on what we learn from the past, we can predict for the future. For example, we learn from the medical domain, let's say. We learn the relationship between different medical staff, and we try to predict what would be the best medical staff to take over in the coming week. We can build a network between different employees based on their involvement in the projects, and we can predict what will be the best team to take the next project successfully. So we build a net driller tool that's fully working. It inspires from the data. If you don't provide the network, it analyzes the data and provides the network to you based on machine learning, data mining, AI techniques, and it displays the network based on your existing data. You don't need to provide what are the nodes, what are the links explicitly. It derives this from your data. It can use fuzziness because humans in general think in fuzzy terms. And I will later on elaborate more on this. Using fuzziness, you can get the network and analyze the network in fuzzy terms to discover what are the important actors in the network, what are the important links in the network, and so on and so forth. So we build the network. After we build the network, we do the data analysis. So there are many screens to allow you to specify your data, your input, and the range for your analysis. I want to analyze the data between two different dates, let's say, and then you get the network displayed. After you get the network displayed, you can process the network. Processing the network means that you can get different measures derived from the network, different centrality measures, and then based on these centrality measures, you can decide that the computer, our tool, will decide on which are the more effective links or the more effective actors in your network. Then will allow you to analyze the network and find how the network will restructure in case you delete some of the actors. We applied this on September 11 network to see how well organized this attack was. It was possible to stop this attack, how it was possible to stop this attack. So we deleted the first level leaders. We get the network continued to be connected. We identified the second level leaders, deleted second level leaders, the network continued to be connected. Third, fourth, until the sixth level leaders, the network continued to be connected. Means it was well planned and they worked hard to get it done. But if you look at Madrid attacks, it was not well planned. It was like rushed. If you have the network of Madrid attacks, after deleting the first level leaders, you get the network becomes sparse. So it was not well prepared. We developed a tool based on AI machine learning techniques to analyze health indicators of a person and compare the person to his or her cohort in the system to suggest how the person should behave to be healthy. So it requires some input from the person who is utilizing the tool. After specifying your parameters, then it compares you to your cohorts and it highlights what problems you might have, what you should do. We utilized for this the Canadian data published by Statistics Canada, and we found the best ideal case for every cohort and compared every person with a cohort in order to suggest what to be done. Because everyone sits at home now, in the past everyone was sitting in the office, it is recommended not to sit on the desk for more than 8 hours. I know of a case where a programmer stayed sitting behind the desk programming for long hours because he had to catch deadline, he got a heart attack. So we built this Sano system that traces and keeps an eye on your behavior and warns you when it is time to practice and do some sports, and can train you how to practice and how to use two sports. Practice your neck, your shoulders, your legs. So it gives you different indicators from green to red, which parts of your body need to be trained. So this Sano was presented at Microsoft Imagine Cup competition and was one of the winners. We developed another tool using AI, machine learning techniques, networks, in order to advise newcomers to Canada where to live based on their indicators. We capture their data and we get what they can do and where they can live. So we developed a tool that allow you to process your data in a general way based on your own understanding. Every person will have his or her understanding of the way you want to process data. As a professor at the university, I may say that a good student is a 70 student. Another professor may say a good student is an 80 student. So everyone specifies his or her understanding of the fuzzy terms. This is captured by the system, and the same data at the end will be processed, and everyone will get his or her own outcome based on his or her own understanding of the fuzzy terms. So this is a fully functional system. So it works with XML, with object-oriented databases, and with relational databases. So to wrap, we have developed a number of tools that can be utilized for different applications in bioinformatics, health informatics. We already worked on some of these, and homeland security. We emphasize scalable techniques for data analysis. We are working on natural language interfaces for tools. We have Virix as another tool that we developed, no time to present that, and we have a natural language interface for that tool. So let me stop here and give the chance to have break, and then we have the next speaker, and after that we'll have the questions. I don't think that we have a question period now. We'll get the questions at that. Thank you for listening, and I will give back to.
Maybe give the
Yeah, I will make you the host again.
Okay, sure.
The host.
Okay. I had planned for, well, first of all, Reda, let me thank you for that. It was actually really fascinating, and some of the tools that you were showcasing, I'd like to have actually further conversation with you about. I'd like to learn more about the net driller in particular. So I had planned, in fact, a bio break at this time. I suggest that we are running a little bit late, and I do want to get to the panel. So I suggest that maybe what we should do is proceed directly on to Mervin's presentation, if I may, and let's go back here. We'll make Mervin, if I may, I'll make you the host. Mervin, are you there?
Yep, I am here.
Yeah, you've been made the host now, so I suggest that we proceed directly into your presentation, if that's okay, and then we can get to the panel afterwards.
Perfect. Everybody should be able to see my screen right now. And the beautiful thing about these virtual conferences is if you wanted a bio break, you can take one, nobody would know.
Indeed.
So let's get started. Now, when we talk about machine intelligence, it's always interesting to see where people see themselves and where it goes from there. Now, White already gave you a bit of an introduction on myself. So the slides will be made available afterwards. So you guys are welcome to read about me. I'm not that interested or interesting, I should say. But having worked all around the world in data and AI now for quite a few years, it's kind of been an interesting journey going through the different maturity levels and being able to work at each of those levels with different organizations. But I really want to get into machine intelligence. Now, when we talk about machine intelligence and when you start researching it, there is a lot of different definitions for it. Some people say it's allowing machines to interact with their environment in a human way, which I find way too arrogant. I don't think we're all that intelligent sometimes. But at the end of the day, the way that we create our reality is through our perception. So for today's purposes, when we talk about machine intelligence, I'm going to talk mostly from a more general artificial intelligence kind of approach, so that we can encapsulate a little bit of a broader view of where we sit within the world. Now, when we look at the ecosystem as it sits at the moment, one of the fun placemats that I always like to look at really shows you how broad it's become over the last few years and the different solutions, applications, software packages, approaches that people take when they work in that. And even if you just look at the AI and machine learning or the machine intelligence portion, which is just a small piece of that, it is still a very large landscape to navigate. And one of the interesting things about this is that this does not even include the thousands of startups that we see popping up every single year. Now, not all of them make it through to full production and survive, but the fact that we are constantly innovating as a species to keep evolving and developing this technology truly is really exciting and great to see. So to start getting into the details, what can all of this new technology actually do for us? Now, firstly, there's a lot already been said about maturity. We saw in the first presentation that depending on how long the technology's been around and how fast it's maturing, different organizations are in different spaces within that journey. Some of the organizations are still very traditional, still trying to figure out how to get self-serve reporting off the operational within the organizations, where some of the more modern organizations are really pushing the boundaries. And in order for that to work, they do really need a very mature data landscape, data architecture behind it to enable them to run all of that capabilities. So data maturity, massively important. And then the next part, and we saw picking the right scenario or the right business case for leveraging AI is important, but I think it needs to go a little bit further. Once you understand what your business problem is that you think you can solve with AI, it's also very important to understand how to marry that up to the right technology and how you utilize that technology. As we're learning more about machine learning and seeing the impacts this have and the unforeseen results when you end up with, like the example showed, chatbots that gets a little bit chatty and off kilter, we realize that we can't just rely on historical information to provide us the input and to these models. And the reason for that is very simple. All of the data that we use is completely littered with bias. It is based on the assumption that the world is not changing. And the data that we use, if we have done something in a certain way, if we use those data sets to predict what needs to happen next, it will just tell us to keep doing the same thing. And that does not necessarily mean it's the right thing. Now, in certain instances, it's a very good thing. When you look at analyzing health, for example, the more we know about what causes good health, bad health, leveraging that information to predict what you should be doing is great. But when we look at social behavior, if we just use the traditional data sets that existed, we would never evolve as an organization or as a society to become better. We would just keep doing what we used to do more efficiently. And that's one of the things that is very important to to me. Now, one of the first use cases I want to look at is specifically using AI and machine intelligence for good. Now, health examples, dementia, I don't know how many of you might have had personal experiences with this, but there are millions of people around the world that really struggle with quality of life as they start getting dementia and getting older and that kind of thing. And when we learned that we could use AI combined with some human interfaces to almost not completely cure it, but manage those situations at the moment, and maybe as we go through that, learn how we can cure it in the future, we do very quickly realize that leveraging AI is not just about making money. And most organizations is about optimization and driving more of their profit focus. But if we really take the time to leverage the technology that is currently available, there are so many more opportunities for us to improve us as a society. One of my favorite books is Max Tegmark's Life 3.0, where he creates a very future leveraging AI, and he paints this picture of how it could turn out if we did things with the right focus, rather than most of the movies that really tend to go more towards the dystopian future where we get killed by AI in the future. So using it for good is important, but most organizations aren't quite mature enough to be able to leverage the technology. They don't have the infrastructures yet. So for them, it is more important to operationalize a solution that drives the organization's remit. In other words, if you're an oil and gas company, leverage machine learning to help make better decisions around technologies to make it cleaner, more efficient, to optimize processes, to limit the impact on the environment. And by using these machine learning algorithms, I mean, the first presentation had a great example of how we can get started in this. And especially here in Calgary and Alberta, there's a big opportunity for that. But there are also some of the organizations that have gotten to the place where they now have little AI teams. They are running these experiments. They've got these agile pods and scrums running, and they're ready for that next step. And when you start looking at self-service machine learning, it really doesn't differ that much from when we rolled out Excel, for example. When Excel came to the market, a lot of people thought, oh, this is a great IT tool, but it very quickly morphed into a business tool used by accountants, engineers, as a data tool to really interrogate the data. And I think we're right at the cusp now where self-service machine learning is the next step to that. It is just a way to extend the capabilities of your strong business users, so those super users in an organization that have the technical know-how, but really are subject matter experts, the engineers, the accountants. And something like BrainToy, one of the local companies here in Calgary, an amazing company, a great platform, and really perfectly designed to help organizations mature into that next phase where they have self-service reporting, and they want to now enhance that with a self-service machine learning capability. Then, of course, AI for discovery, really trying to push the boundaries. Tesla is doing a great job at this, utilizing all kinds of models to bring up new technology, new products, self-driving cars. But we very often forget about the side effects of those. Things like, for example, the moment you've got a self-driving car, you can apply that same technology to planes. And as soon as we can start flying again, I used to do a lot of traveling, and being grounded because of fog was one of the most frustrating situations I ever found myself in. But with the new AI technologies that's being developed for self-driving cars, we could finally get to a point where fog doesn't keep us on the ground anymore, and we can actually evolve planes to the point where they become a lot safer. I mean, we've seen a lot of challenges with air travel in the past, but leveraging this advances in technology in other areas could be applied to help solve some of those problems. And I really hope we solve those before we get into some of the new hyperloops or some of the technologies that we're trying to get to the future. Because being stuck in a plane in the air, you can still glide down, but when you're in a tunnel underground and things go wrong, make sure the technology works before you put that into production, which is where the disruptive AI component comes in. Now, when we start looking at how SpaceX, for example, is automating the landing of their rockets, the reuse of this, bringing the cost down exponentially, it is now allowing us to launch thousands and thousands of satellites almost on a weekly basis. And the disruptive nature of that, where now all of a sudden we can provide internet to rural areas anywhere in the world pretty soon. And it's incredible to see the impact of that, because from a technology point of view, it obviously is very exciting. From an operational point of view, now you have to start wondering, how do you launch these rockets that you've now made so cheap, because there's so many satellites in the atmosphere, and you need to know how to navigate that. But more importantly, what happens when you can now provide education for people in rural areas in Africa, which haven't been able to access those services? The change this brings to us as a society and humanity as a whole is extremely exciting. So very happy about that. And that's where the ethical part is a big focus for us. With the company, my company Augmented Humanity, we really do focus our product development around the ethics of humanity and how to improve us as a society together, and not just isolated as a individual. So really putting our global best will ahead of our personal gains that we can get through this. So the value creation really is where this becomes very interesting, because as we start building these products, we spend so much time trying to get all of the data together. Where does it come from? Being able to access the information you need to build these models, train these models. And then, of course, how do you arrange it? We just saw in the previous presentation the limitations around data storage, the acquisition of it, the transport of it, and then, of course, the modeling pieces. We're starting to get into a much more complex environment where network graph databases is becoming more popular. And as we move into quantum machine learning algorithms, we're starting to look at not just the normal traditional structured data, but now we've got into multi-dimensional data sets. And adding that complexity to it really does push the barriers quite far out. Then, of course, data integrity. Now, this is something where every organization struggles with, the data quality, lineage, all of those kind of things. But one of the things that people forget is the accuracy of the data as it pertains to the situation. So not just are the facts correct, but the context around that. And we see a lot of challenges in the media about stories of events that happened, and depending on which channel you watch, it feels like you're on two different planets, even though they are talking about the same event. And having that integrity around your information has become much more important for us as a society, to drive this wedge between people, to push them towards the extremes, really is not helping us to work together and collaborate and make the world a better place. So one of the things I believe we have to really focus on is that integrity of the data, the context around it, and how we interpret it moving forward. Now, one of the beautiful things that I love about AI and machine learning is the fact that we can now start automating a lot of that processes, not just the presentation of it, where you can create dashboards and scorecards and visualizations, but you can start automating the acquisition of it, creating bots that goes and gets all the data. You can start automating the modeling of it, using the context of existing models and tons of data out in the world to actually contextualize and create those models for you automatically, accelerating the time from start to finish, and really allowing us as humans to do what we do best: hypothesize, test our hypotheses, learn, grow, adapt, and come out with new solutions as we move forward. So I think we're just about up on time. So I hope that this really just tweaked your interest in the space. There are so much to talk about, and depending on if you're a more traditional company that's just getting into machine learning, or if you're a bleeding edge company that are developing technology based around some of the latest Neuralink technology or human computer interfaces. Most people know about Neuralink, but they don't know about the 10 other companies that's building the technology for us to make the matrix a reality. So if that excites you or scares you, it's definitely something we all need to be talking about, as it is something we are working towards as a society very fast. So I think we're ready for the panel, I believe.
Indeed, Mervin, thank you.
Perfect.
You make me the host if you like.
I am making you the host. You should be the host right now.
Yes, I am. Thank you. Okay, well, thank you, Mervin, Reda, and Brian for sharing your thoughts. And now, actually, I think is the I think it's kind of my favorite point is when actually the three speakers are able to speak and to share ideas. Now, the way this works is that I'm going to invite again the audience here to submit questions that may occur to them as we go forward. And I do have a couple from previously. I'll just open that in the chat. And so I may direct some of these questions to any one of you, three speakers, but of course, any of these questions is open game. So you can certainly respond. Brian, I think that since you are actually positioned to speak to a very wide range of businesses today in your experiences as VP, I'm really interested in what you're seeing in this space in the Canadian or just the Calgary landscape. Maybe also if you're seeing that we're lagging behind the States or other regions.
Thanks, Wade. Yeah, there's when I look at our neighbors to the south, there seems to be a lot more uptake on general sort of advanced analytics, AI, ML. There seem the organizations are adopting it. Now, part of that could be, they're 10 times bigger than us, and companies we may think are big here or even bigger there, big to invest in those. But there definitely is much more interest, south of the border than in Calgary, and we're seeing that in our US operations. Locally, I've seen, yes, there are organizations, and there's big organizations that are investing in advanced analytics and AI, and which is great to see, and some really embracing it. I'm really intrigued by this startup community in Alberta. Really, there's lots of companies who are adopting AI into their products, core part of that. Great to see organizations sort of being, disrupting probably various different business domains by building products that are based on AI. So that's really interesting. The large enterprises are investing lots of money into that, mainly with the idea of, how do I reduce costs, do things more efficiently, perspective.
Thank you. And Mervin, I wanted to ask you, actually, you and I have been working in what I would call traditional analytics for a long time. But we also hear there's kind of this rumbling out there that the data warehouse is dead and so on. I'm really interested in your perspective, and Reda and Brian as well, in that term that the data warehouse is dead, and what you see the position of what we call traditional analytics in the modern data center.
Well, the interesting part is it always depends on who's saying that it's dead, right? The guys working on the bleeding edge, for them, it truly is dead. But there are so many organizations that are in a very different space on that maturity platform, or on that maturity levels, on the journey towards where these bleeding edge companies are, that for the next 50 years, they will still be very much reliant on traditional data warehouses, working on creating a BI center of excellence, creating report, eventually getting self-service reporting. And the challenge with some of the more older traditional organizations is turning those big ships are very difficult and very slow. So the change doesn't come as easy. Whereas if you have a new startup, you can within a matter of weeks have all of the latest technology, leveraging lots of these new fun toys to accelerate your delivery, which means that for them, it is dead. But it doesn't mean that it is completely dead yet. I don't think anybody in the workforce right now needs to immediately go and sign up for a university for a new degree or something, because they won't find a job next year because it's dead. There'll be lots of data jobs available for a long time, but honestly, like our startup, we don't use data modelers anymore. We don't use integration developers. We don't have a need for any of it, because we use AI to automate all of that. And it's a lot of fun, but it does need a certain environment to work in. So yeah, yes and a no.
So let me add here, if you look into the 90s, data engineering was very popular because people wanted to move their data, and then it failed a lot because it was not possible to understand all the current data models and how they work. And then people started to think of wrapping the existing data and expanding their data processing capabilities. So data warehouses will continue to exist, I guess. And new techniques, new technologies will come aside with data warehouses, and we'll have big wrapping, and then we can get from data warehouses what is in data warehouses, what in the other tools, other techniques will provide whatever data warehouse cannot provide. But as Marvin said, data warehouses will live with us for at least 50 more years, maybe.
Indeed, they've actually been around for also about 50 years in various forms as well. We just weren't necessarily calling them data warehouses. So I wanted to get into ethics, and actually, Mervin, you actually alluded to this a little bit, and this is actually pertaining also to my work as well, is with the power that is available with well built, artificial intelligence, machine learning, neural nets. The risk, or there's an increasing risk when it's not, when there isn't a mindset of ethics to really in being very intrusive, risking people's privacy and so on. So, maybe just I'll throw this out to the three of you. How do we respect individuals' privacy when we're trying to get this deeper insight? It's very, very seductive. So what are kind of like, I'm just interested what your thoughts are around that.
I think there's a few things you need to take into consideration here. People have this idea that they have privacy, but they don't treat it as such. If you parade naked on the front lawn, your neighbors are going to see you, and there's nothing you can do about that. But people don't treat their data the same way. They think they can throw it out there onto all of these social platforms, and then are very upset when people use it in a way that they didn't intend it to be used, right? So privacy, number one, is something that you control. If you don't want people to know, don't put it out there. But once it's out there, this concept that if it's out there, this system will keep it safe and secure is a fallacy. Nobody can guarantee you that. And even governmental regulations, GDPR wants to enforce this concept of the right to be forgotten. But who have you gone and introduced yourself as? Hi, my name is Mervin. Oh, sorry, I wasn't planning on doing that. Please forget my name. You do not know my name anymore. We don't operate like that as humans, but for some reason we think that way. So there's definitely that component. But from an ethics point of view, we can make this a really amazing technology do what we want. It's same like figure out how to split an atom. You either build a bomb or build clean energy. And we're trying to push towards both of those, it seems like, is with examples like Cambridge Analytica driving to swing governmental elections, or for getting Brexit to be approved, and all those kind of things. Is maybe one of the most prevalent things because there's a profit attached to it. There's a reason why companies want to do this. But you could use that same capability to actually improve life, make people healthier, help them to be better. Now, the true ethical question is, do you give them free will or do you take that away? If you know that smoking will cause you cancer and kill you, if you can influence the world to stop smoking, and doing that takes away their free will, are you actually doing anything better than people trying to do it for profit? So it's not an easy question to answer, and it really does come down to personal belief.
Reda, Brian, thoughts on ethics and and the concern for invasion of privacy in this space?
There's I have some clients and work with some clients, and I've looked at some of their data and I've looked and said, are you actually allowed to use that for your analytics? Did they give you permission? And it started a whole conversation with them where they're actually going down that road and saying, you're right. We have some information we gathered 30 years ago. Are we able to use that data? And so I think these questions are being asked, and that I think is really important. People need to understand. But on the flip side, I've had organizations that are very rigid and said after 7 years you need to forget all this data, and we're going, hold on, what about my analytics? What about the things I'm trying to learn and model for you? What information do we need to forget about individuals? And through that process, it needs to be a discussion. It's a balance point, because a data analyst perspective, I want all the data possible to be able to go in and do it, but you need to use it in an ethical way and respectful way. Make sure you have permission to use any data that you have, and but also not flip on the other side to say, well, we're going to throw away everything we learned and we're only going to look at the world in a 7-year view.
That's a good point.
So let me add here, I guess it depends also on where the data is collected and how data is processed. Because if you hear many of the messages comes to us on the phone when we call these organizations for electricity, for gas, for others, that data is collected outside Canada. Means that rules other than the Canadian rules apply for privacy and other things. So when the data is collected, you trust who collects the data, but whether you trust them and they are really trustable or not. And every person has his own concerns about privacy. For example, now with the pandemic in Canada, we are not allowed to ask the students to open their cameras for the exams. You don't know who is taking the exam in the backend. Some other countries enforce students to use 2-3 cameras maybe to control them all the way. So it depends who is applying the rules and how the rules are applied, and the trust is important here.
Thank you. I mean, further into the ethics piece is also bias. many of our data sets have bias that we perhaps are not even aware of, or even especially perhaps even more so historical data might have biases that may have been societal at the time as well. So maybe we should just talk about, as the three experts in the field is around, selecting or preparing a data set, working to eliminate the bias in a training data set before going into the actual training process. How would you approach that?
I think it's a little bit premature just to extract all bias, because then you lose a lot of context around it. The bias exists because of a reason, because of our environment, because of our economical situation, because of what's happening in the world. But being aware of it, I think, is the true key. Knowing that there's bias in there, and then using that to influence how you apply the knowledge. So if you train a model, I use this example at the bank quite a lot. If you want to know loans to, who to lend money to, if you look at the history, we've done it, we've given loans to 30-year-old men with a job that's white. So by just looking at the data, you're going to not be able to provide the right service moving forward. But knowing that, we can start looking at, okay, so that's biased. What else do we need to look at? What data do we need to look at? We need to look at how things are moving forward, what is changing, changing which parameters we use to train our models, so that we take a more intelligent approach to it and actually use that bias to prevent or to evolve us to a place where we are stronger and better, and we can actually remove some of those biases in our society moving forward.
Thank you. Actually, Mervin, I want to come back on your presentation. Mike Bauer from ArcCurve actually asked me a question. You mentioned a company. Was it Brain Toy?
BrainToy, braintoy.com, a great company born here in Calgary. It's a machine learning platform that allows you to roll it out to the whole organization, to engineers, accountants. They've got training, everything. It really does allow an organization to get that the foot into the door when it comes to self-serve machine learning, and especially in the engineering space. We have a lot of engineers right now that are already data scientists in a sense, because they are doing all of this analysis work, but they just don't have the right tools to do it at scale. And by giving them access to those right tools, you now all of a sudden allow them to accelerate their insights exponentially. So I think in Calgary specifically, we have an opportunity here that is missed. It's not a big data platform yet. It's still a growing platform, but it is one of the best out there.
Yeah, in Calgary, we have, like Reda said, I think as well, we have a fantastic startup culture here in Calgary. One of the things when I came back to Canada in 2013, it blew me away. In 12 years out of Canada, coming back, the landscape had completely changed. And there's like a lot of incubators. There were at that time a lot of grants available for them as well. So, we're seeing that, for example, Edmonton is becoming a real strength in AI. Alberta, with our educated workforce and our innovative mindset, we're really well positioned to also become leaders in this space in Canada, at the least. Rid, I wanted to ask you a question as a researcher. Where do you see the algorithms and statistical models taking us in the next 5 years?
I guess we'll be able to develop new algorithms and techniques that can analyze larger volumes of data, because we have already proved that we can do with large data using distributed systems. So using Sparks, Hadoop, we can analyze huge volumes of data. So we can expand now the algorithms for larger data and to dig more in the data to make the better sense of data.
And as you're kind of an expert, this is an area of your real interest is in data mining. Data mining really came to my mind from OLAP Services very, very early on when Microsoft acquired it from Panorama. But how would you characterize or differentiate what we call data mining, I guess then or even now, versus AI, ML, neural nets, and like true like data science? How would you contrast that?
So data mining is knowledge discovery in the data. It is less that let me say it like that. It is not AI. It is part of the AI, but AI is wider perspective than the data mining. Data mining is to discover what is implicit in the data, but AI is to learn how to behave based on the data for independently, autonomously. For example, distributed AI, you have the multi-agent systems that learn from the environment and try to behave based on what they learn. Data mining is not any of that. So data mining is discovering implicit data, content of the data which cannot be extracted using conventional techniques which were dedicated to extract explicit data.
Thank you. Maybe I'll ask this. I'll throw this out to all of you actually, and I'm interested in what the challenges you see in adoption of this type of technology in larger organizations, and also further on, is there a specific kind of approach to change management that you might take to bring what might be seen as a very new and potentially, I don't know, I don't want to use the word scary, but let's just say scary technology, to have that penetrate and productionize that. So kind of two questions. How do you drive adoption, and how do you manage the change management behind that? That might be unique to this technology.
So mostly people try to stick to what they are doing. And these new techniques, new technology is not to be learned by training, it is to be learned by education. For example, if you look at the University of Calgary, you will see many certificates are out there to educate the people about the new technology, the new developments in the industry. So in the past, they were training and they failed in many occasions. For example, now many of those in the market try to learn Python and claim themselves as data scientists based on their knowledge of Python. But behind Python, there are many things to be learned in order to be claimed as data scientists. So they have to get educated people, not trained people. And they have to accept the change, and they have to accept that the change is not replacing them. It's expanding their power and capabilities to cover more than what they were covering in the past. So those who exist in the company will continue to exist, and their expertise will continue to live and continue to be valuable, and new expertise will expand the vision of the companies.
So when we look at large organizations, and Mervin talked a bit about this, it's sort of like trying to move the Titanic, right? It just takes a long time to move those, and smaller organizations are better able to go in and adapt. And this really has me thinking about kind of the innovative dilemma where, how do you change an organization? It's harder to change it within and without and kind of outside of it. And how do organizations structure themselves so that they can take advantage of innovation? Organizations are adopting innovation and doing things like innovation labs, advanced analytics groups, which are kind of semi-separate. Having a bit of autonomy in there to go in and adopt some of the new technologies. In the traditional large company, are you going to go up to your CEO and say, hey, we just did an experiment and we blew $100,000 and we found that there's no solution to this? Well, it's probably career limiting, right? So the way that large organizations work, they don't like you, being unsuccessful. You've got project managers, PMOs, you've got, functional managers, all looking over what you're doing and trying to evaluate it in the instance, rather than saying, no, we need some space to be able to innovate. We're going to make mistakes. We're going to learn a lot. And then hopefully this will disrupt your business in the way that is very positive. Because if you don't change, you will die. I don't see, Kodak making, lots of money and making films, and they lost their opportunity in the digital world, right? There are lots of use cases for those kinds of companies that, are maybe at the top of their game, but through lack of innovation and not able to make it. And AI and advanced analytics, all these are really focused on how do we change how we work, and that's really hard.
I love that comment, and the value and importance of innovation, experimentation, acceptance of failure as actually a symptom of success. I love that mentality, and it's true that adoption must occur. That shift and movement away from rigidity.
Yeah, and I think one of the things that we need to keep in mind, like Brian just said, Kodak didn't make it, but in the last year before they closed doors, they registered some of the most innovative patents related to film development. They had these little labs, the little pieces in the company that was doing this. And this is the risk we run at starting an AI team over here in a corner and thinking that the marketing we get from it and the fact that we now have data science in the company is going to change us. It doesn't. It just creates this false sense of, oh, we're moving forward. The only place where you truly see real innovation is if it comes from the top, if it is the executive, the CEO that has that mindset and is willing to accept the risk. Like you said, Wade, like if you look at Elon Musk, when he rolled out the latest Starship 9, there was zero expectation that that thing would not explode. He already had Starship 10 right next to it on the landing pad. They did not expect it to land because every time they lost those hundreds of $millions when that Starship exploded, they learned so much that they could move it forward. And that is the mentality that you have to take. Like one of my favorite CEOs, Dave from ATB, who's now retired, when they went through the digital, or when we went through the digital transformation at that time, his vision to transform the whole organization was what drove them to switch from Microsoft to Google, get a whole executive that didn't know what an iPad was other than this thing that you use to put your coffee on, to a point where we were able to get the whole board and executive with a bunch of 12-year-olds from school learning how to use Google on an iPad. And that vision, that innovation that is driven from a CEO, that is what truly transforms an organization.
We're moving towards the end of this, and I want to come down to two questions here now. And I want to come down and really shift. Now we talked about data structures, data warehouse ecosystem kind of thing. I want to move towards the future view. So I'm going to start with you, Reda, if I can. I'm interested because you are really in a hotbed. I know some of your colleagues are doing some amazing things in bioinformatics and image processing. What are some of the most interesting applications, Reda, that you're seeing in your own research and those of your colleagues that are exploring right now? What's hidden behind the covers of the UC right now that's really amazing?
Oh, we are working on different aspects of data analysis in bioinformatics, health informatics. We are analyzing, let's say, images to discover the diseases based on sample analysis. So we have developed a system where you can see under the microscope the sample of a cancer patient and highlight what could be the cells that are infected by the cancer for the pathologist to confirm those or to learn from the system. So we are developing, the University of Calgary is very good in security. And we have a team who work for the Bank of Canada for the Bitcoin project. So we are good in human-computer interaction, many developments there. and many collaboration with the industry in the human-computer interaction side. So there are different things going at the University of Calgary, and we are open for collaboration with the industry on different aspects of data analysis in all domains, from health, financial, security, you name it.
Thank you. Fantastic. And this comes down to my final question before we go into closing and wrap up. And that is, what is the bleeding edge? This is for all three of you. What's a bleeding edge? What are the outer fringes of potential that we're seeing now? What are the ideas that have legs in the coming years that you're seeing?
Well, that's a very interesting question, and I hope you guys aren't squeamish or too easily scared, but the biggest we face is right on the edge of ethics, and that is as we move to human-computer interfaces. If you're able to bypass the senses, the sight, sound, taste, all of that, and you can connect straight to the core, the brain of a human being, and create that environment, let's call it a virtual environment, how would that person know the difference between reality and what is being fed to the brain, the physical reality outside and not? So we're doing a lot of research right now around how people interact with fake realities. Now we use a lot of VR right now, but as we start to work with more of the human-computer interfaces, it is becoming more and more important for us to make sure that when you are fed information, that you are still in control of how you actually interact with that information. The same way one person putting on a VR headset that falls off a building literally falls over on the ground versus somebody that just laughs and knows that they are in a virtual environment. When you start bypassing the senses, you don't necessarily have that decision to make yourself anymore. So the research we're doing in that is truly matrix, green pill, red pill, or what's it, blue pill, red pill kind of challenges.
So I guess autonomous systems are the most important in the near future, and developing more advanced autonomous systems. But the key question is, who will be responsible for the fault of the autonomous systems? Now, if you have a car accident, you get ticket. Now, if the autonomous car will get an accident, who will get the ticket? So there are many rules and regulations that should be set before we are ready for these autonomous machines and to have a fully automated process.
Even the effects on legislation then in that case. Interesting.
Yeah, and I'm going to take a little bit of a slant. This is maybe gets me excited, and I look, as we use technology, any technology, often we rely on it, and we build technology on technology. And I think that this is what we will be seeing in here. I can imagine that we will see AI building blocks that we compile together in the future to build complex solutions. And the issue with that is we go in and we're going to lose the inherent knowledge of all the things that we built upon. And that loss of knowledge, understanding, let's say I'm going to use this service and it uses some complex, AI algorithm underneath. If you don't understand the algorithm, how it works, you may not know how to interpret how it's behaving. And so it's, as we go in, we build upon AI technology, and the world forgets how it actually works. That's what scares me, because then we sort of lose that control or knowledge.
Well, that's actually interesting. And just I'll finish with this, that I read an article recently that was saying that we are forgetting how to do things. So actually, the skill to be a storyteller is becoming more highly valued in organizations, because they can paint the picture, because as we tend to automate and build these systems, we're forgetting how we did it, which is pretty terrifying when you think about it. So I think that looking at the time, we're coming up on the hour. I'd like to thank you three for sharing your knowledge, experience. Reda, I know it's nighttime for you. Reda is joining us from Turkey. Thank you for sharing your evening with us, Reda, Alhajj. And Mervin, Brian, and Reda, thank you again very much for joining us and sharing your knowledge, expertise, and vision with DMC today.
Thank you for inviting us. It's a pleasure.
Okay.
Thank you.
Yeah, my pleasure. Thanks, everyone.
Thank you, guys. Sign
Bye-bye.
up. Bye-bye.
Right out.